Hey, this is Tom from Audio Ordeal, and I am going to be showing you how to make a synth in Reaktor from scratch. So what we have is we have our basic edit view. So we are on edit, and you just file, new ensemble. We can do split screen, so we've got the panel up here, and we have the actual modules down here. Now then what I'm going to do is I'm going to get these dragged over, and we're just going to delete the inputs because we do not need them. Right, so what do we need for a synth? Well, you have a keyboard and you have the output, really. That's what's on either end of the synth, and so that's what we're going to start off with. So built-in module, Midi in, let's get the note pitch. So every time you hit a note, it sends a number. For example, middle C would be 60 is the MIDI number for middle C. And also we want to add in the gate, so every time a note is pressed it sends 1, and that just triggers when the note's actually pressed, and every time it's released it turns back to 0. Let's go and get another built-in module. Let's go back to MIDI in. Shall we do velocity? So what we do is we measure how hard the note is pushed. Not all MIDI keyboards can do that, but if we push it soft it might be a value of maybe 30, 40, and the hardest we can do is 127. This is because it's 0 indexed, so 0 counts as the first number, and if you think we have 128 values that we can do, standard computing, 32, 64, 128. So if we got 128 values including 0, the maximum we can do is 127. So 0 base indexing is something we should actually pay attention to when we're programming in Reaktor, because there's a lot of modules that use 0 as the first index, but there's also a lot of modules that use 1 as the first index. So quite often we'll need to use an add or a subtract module to add or take away 1, just so it's all in the same index system. But that's pretty simple, and that's a bit more of an advanced technique that's worth bearing in mind from the start. As soon as we use stuff like velocities, you're technically using it. Right, so what we have so far is the MIDI inputs. I will show you what other inputs we can do. We can do stuff like aftertouch, and we can also insert clocks and start and stop and everything. At the moment, all we want is these three. You hit the note, it tells you which note it is, it tells you when you've hit the note, and it tells you how hard you've hit the note. So for our basic synth, what we need is an oscillator. So let's start off with the most basic of waveform, a sine oscillator. So it has two inputs, pitch, which is the input for control of the pitch, and it tells you all the different data that it receives, and then the amplitude control, so it goes from 0 for off to 1 for full volume. So let's say we just connect this to the output, and we set the pitch by just create a constant at 60, so C. What we can do, we can create a control, and at 0 it's off, and it goes higher and higher in volume all the way up to 1. We don't want to do this because we want it to be controlled not by a constant but by the MIDI keyboard itself. So let's do the note pitch to the pitch. Gate sends default range 0 to 1, as you can see at the bottom of the information panel, which matches up with amplitude range 0 to 1. So let's just play about. Let's see if the keyboard works for me. Hopefully it does. So I'm now touching my MIDI keyboard and I am playing different notes. Now you can hear the audio is not very great. That's just because we have the very basic steps. You could argue that this is all that you need really for a synthesizer, but of course that's no good. So what else does a synthesizer have? Well, it's got the attack envelope, which we can open up envelope, and let's just do ADSR, the most common of all of them. So this sends an output of 0 to 1, and instead of just on or off a binary value from gate to there, we can send it so it goes up to 1, down, and then releases back to 0, as can be seen in that picture there. So this just controls it's basically the control of the transition from 0 to 1 and back down again. So what we do, we connect the gate to the gate input. So as soon as 1 is sent, this triggers this, and then whatever time the attack, decay, sustain and release have, that's triggered and then controls this. So let's just add controls. So create control, create control, create control, and create control. Now then, you will see on the panel that they've all loaded on top of each other. So unlock panel with either the lock button or Control E, and we can drag them out. Just like so. And then we can move it about. So currently we have our ADSR. So if I was to play a note, you can hear it goes up and then back down. And then 0 attack, it just kicks in all of a sudden to full volume. So I'm assuming everyone has a rough idea of how ADSRs work already. That will make the next stage easier. If you don't, it's fairly obvious. Each step just controls the timing, except for sustain, which controls the actual volume that the note is held at. There are plenty of videos online that actually explain in much deeper detail what an ADSR is, but for the brevity of this video, let's move forward. So we have our sine wave. Let's make it a multi-waveform synth, so let's choose a pulse. Now then, if we just take that off and take that off, we can suddenly use a pulse wave. But we want it to be switchable. So there are two ways to do it. We could switch beforehand or we could switch after. This is where Reaktor starts getting interesting, because if we switch beforehand, these signals are routed to only that module, which then goes out. If we switch afterwards, the signals go to both, so both oscillators are processing that signal and generating audio before going out. So it really depends on what you're sending and what sort of routing you want, and it very much also depends on the complexity that you're going for. Sometimes one's better than the other. We're making a fairly basic synth, so it doesn't really matter. So in which case I'm actually going to just make the switch afterwards, because there's one output, so just two inputs on a switch. This has 2 inputs each, so we'd need to have a slightly more complex switch system. So built-in module, it's not under signal path, sorry, it is under panel. So panel switch, we'll drag that on. Now it's not got another input, that's because we need to click on this, hold control and drag it over. While you hold control, it will add an extra input, and it's always good to rename them, sine and pulse. That way on the switch, you won't just have 1 and 2, you'll actually have the name of it. And we can change switch to waveform. And when I hit enter, that will change the title of it, waveform. Now we can just send this and send this. Let's have a little listen. Let's lock that so we can play about with the controls. Select that. Now then, you'll see at the start I had to select one of them. The default there isn't on, so this can be easily changed. Click on that. In function, the default's at 0, so let's just make the default value 1, which is the first option. And if we just set this to default, when you load it up, it'll be on sine, and you don't need to click one of the waveforms. Just like that. And basically, that is the initial premise of having a synth. So if you stay tuned for the following videos, we'll go way more in depth, but we can, from here you have the basics, like the template. You can add different oscillators, route them all in, add it to the switch. But yeah, that's the very basic premise of a synth. I hope you give this video a like and subscribe, because there are plenty more to come and we will go fairly deep into this. So thank you for watching.